In the first session, we just installed ZIG binary and had a quick intro at ZIG. And this will say hello world to my ZIG. So let's create a fresh directory and init a ZIG project with ZIG init. The core source file for binary project is src main ZIG. If it were a library project, we would have deleted this file and treated the root.zig file as the same path as a core. This already shows some quick code pieces like debug print of stdlib and stdout writer with buffer for print, pattern for writing simple tests for each block next to them, creating an error list, and defer memory reallocation for it. It's been some time, so I'll try ZIG build, help. Run and test are what we'll mainly be using. We see that debug and stdout print out from main here. Let's tweak tests to see pass and fails. Add an extra pop to make it fail. Run ZIG build test. Let's push 2 to it. Messing about the wrong order to fail again. Fixing the order to pass. Taking a quick look back at files generated by ZIG init, there is main.zig focused for executable projects that need to declare a main function, and root.zig for library oriented stuff. Each .zig file is a separate ZIG module. Let's delete function and test code from root.zig to see its impact. It raises error for add call that when we check gets used in test block in main.zig. It's available via import of the same project, giving access to the public exported add function. There's also build.zig script that provides capability to ZIG compiler's build subcommand. ZIG compiler has the build system within it as well as modern compilers. Other file build.zig.zon is ZIG package manager configuration file. Zon manages dependencies. Every statement ends with a semicolon. Add import is a built-in function similar to hash include precursor of C++ to include available libraries. Assignment syntax is standard, uses const and var for immutable and mutable assignments respectively. Function declaration is similar to C as well, starting with scope if any, fn to declare the name, parameters with their types after a colon, separated by commas, and then return type, and definition within the curly braces. ZIG is strongly typed. Mention of type can be skipped only where inference is absolute. So function parameters and return types can't be omitted. Export keyword in function definition exposes the function to be available in the library API. Every function is default private to module, if not made public with pub keyword. So you'll see pub export in root.zig and pub fn main. So let's write a simple multiply function, a dump copy of add, and export it to be utilized in main. Let's add the test as well so we can run them and see it pass. Giving it a try in code. In main definition, the return type is exclamation mark preceding void. This mark states in ZIG possibility of mixed return type that could be error or type after exclamation mark. So in case of main, it may return error or void. If a function may return error, either it is to be reflected in return type or it must be handled within the function definition itself. ZIG has try-catch keywords for error handling, but the use is not entirely traditional. As in our generated main function, ZIG's try executes an expression that might return an error. Try does nothing if there is no error. If there is an error, try unwraps the error value, prints current stack to stdr, and return error value from function. It doesn't just panic there, and in essence the error bubbles up, so you are forced to manage it. Main also has the pub keyword attached to it. Now to compiling ZIG, build exe src main ZIG builds an executables. Similarly, we have build lib subcommand to compile module into a portable CABI library, or build obj to compile into an object file. Build exe compiled the main file into root of project. We do have a ZIG out directory, but that is a result of an earlier run build command. I'll just quickly clean up old remains. ZIG run src main ZIG to build and run in a single step. Prime for dev mode, not release. There's a special note for Windows users. In concept, similar cases may occur for different platforms for different niche flows. Here it mentions ZIG in cases failed with stdout when it was compile time evaluated for Windows releases due to being in the global space. So moving it within the call of main worked for Windows, thus removing the comp time evaluation. ZIG build command goes beyond build.exe and such to explore constructs mentioned in build.zig and work as a more complete build utility for ZIG projects. This will generate the target binaries and libraries in ZIG out directory that we just cleaned a few moments back. Other than this book, it mentions more active places to learn and explore ZIG. In my understanding, ZIGit community is at the core and very active. There are also several popular projects now to explore like JS Runtime Bun, a financial database Tiger Beetle, ZigClap, and often used CLI arc parser package. It also has links to a few official and unofficial code reference materials. Now moving on to identifiers. As we already saw, const and var keywords usage for new identifiers. ZIG does have undefined keyword, helps to initialize a new identifier with when we know its type but not value, and just giving a base value like 0, false, or an empty string conceptually defeats the purpose of no value available yet. Also, ZIG enforces you to either use the created object at least once or explicitly discard it by assigning to an underscore character. An object assigned to an underscore is destroyed by the compiler with no further use. You must mutate the variable objects as well, or else you'll get a compiler message to either use it like immutable or define it as a constant. Giving it a try in code just to remember better. Now a quick look at primitive types. Similar to traditional languages like Rust and Go, it has unsigned and signed integers, floating point numbers, and booleans. It also has C API compatible types like CLong, CChar, and more. A few pointer sized integers as iSize and uSized for the signed and unsigned. Many more to be explored while writing code that might need them from language reference page. We'll explore array initializers in the next chapter.